Hi, in this video you will be learning how to factor a greatest common factor from a polynomial. This will help you as we get into factoring quadratics in Unit 2, Module 2. So GCF stands for greatest common factor. Greatest, I want you to think highest. Common, well, in common. That kind of makes sense there. Oops, if I can spell today. And factor, these are things like these are the numbers that when multiplied together produce a product. So in other words, if I ask for the factors of 8, you might say, well, 8 and 1 are a factor, and 4 and 2 are factors. So again, factors are the numbers that when multiplied give you a particular product. So our job in this lesson will be to pull out the greatest common factor so that we can rewrite it as the product of two expressions. So for number 1, these are just the first 4 are just going to be examples that I have for you to include in your notes. If you're listening, please go ahead and put the date up here. Today's date is 9/17/20. So for number 1, I want you to factor completely the expression 5a minus 20. So a lot of you will go, well, we factored in Math 1 and we factored in 8th grade, so this makes sense. These have a factor of 5 in common. So there's a fast way where you can just say, okay, I know that 5a and 20 have 5 as the highest common factor. Therefore, I can pull the 5 out and then write what remains in parentheses. And what goes in parentheses is what you get when you divide out the common factor of 5. So 5a divided by 5 cancels out, leaving the a, and then negative 20 divided by 5 is 4. And you're through because a and 4 do not have any common factors. So that's important. When you pull out the GCF, you want to make sure that there are no common factors left in your parentheses. You can also check it by distributing real quick. 5 times a is 5a. 5 times negative 4 is negative 20. If you feel like I'm going too fast, remember to just pause anytime to be able to get this in your notes. I also want to share with you that just like we used in the last unit, you may verify your answer by going to Y1 and typing in the problem, replacing any variable in the problem with X. And then in Y2, type your answer. And if that is correct, then when you look at your table, your output values for Y1 and Y2 will match. I apologize. Let me get this to focus for you. So anything I do on a calculator, you should be pulling out your phone or a graphing calculator and doing this using the appropriate app. The Calculate 84 is the one we use the most because Miss Ellen and I have Apple phones, but certainly you can, or iPhone, so you can, if you have an Android, use that Wabbit Emu app. And if you're still having trouble with knowing what calculator app to use, please send us a message so we can help you. So I'm going to hit second and then the graph button to look at the table. And you can see that all my Y1 and Y2 values match. All right? So that's the answer. However, some students have difficulty with factoring this. So I'm going to show you an alternative method if you're like, I didn't understand that. So what you're going to do is write out the prime factorization for every term as you see it. So 5 times a, 5 is a prime number, and the only way I can write that is 5 times a. Then I put my minus sign. And then I want you to think about using a factor tree for 20. If you use a factor tree, this is 2 times 10. 2 is prime, so I'm going to put it in my list. And then 10 breaks down to 2 and 5. Both being prime numbers, meaning I can't find any other factors other than 1 in itself. So this is the prime factorization. I'll put PF here if you're still listening. Prime factorization for 5a minus 20. So while it might be longer to do for each problem, it's kind of a surefire way to get it correct, because if you circle what they have in common and put that on the outside, then start off with parentheses, and all you have to do is list what's next. 2 times 2 is 4. And it works every single time. So 2 different ways. You can either look at it and determine what the common factor is. It has to be the highest common factor, the greatest. Or you can do this method, making sure you break all terms down into prime factors, and then circle what they have in common. That goes on the outside and is multiplied, and then anything left stays in parentheses. All right, so for number 2, 9x to the 5th plus 30x squared. So this one's different from the last one in that we have two variables, or two terms with variables but with different exponents. So again, if I were to think about this like breaking it down, I might say, well, 9 is 3 and 3, and I have 5 x's in common. Or excuse me, I have 5 x's for this first term, not in common. So 3 times 3 times 5 x's. Plus this here for 30, that breaks down to 3 and 10, but 10 is 2 and 5. And I have 2 x's. If I circle what they have in common, I have a 3 in common, so I'm going to write it down. I have an x in common, so I'm going to write it down. I have another x in common, I'm going to write it down. And what's left is 3 x's, which is x to the 3rd, plus 2 times 5, which is 10. And notice I don't have anything in common here. So we can't leave 3 times x times x. Remember that when we are multiplying like variables, we add their exponents. So we're going to put an exponent of 2, meaning we're multiplying 2 x's together. And this would be my answer. Now this is correct, but I don't expect every student to do this. So if you can look at 9 and 30 and say, well, clearly the highest number that they are divisible by is 3, you go ahead and put your 3 outside. When you look at your variables and you go, oh, they have the same variables, I always choose the one with the lowest exponent because this means that they have 2 in common. So I'm going to put 2 here to represent that they have 2 in common. So I'm kind of out of room here, so I'm just going to come up here. And if I have 9x to the 5th plus 30x squared, and I say that they have 3x squared in common, some students can do it visually. I like to write it out for students until they catch on. What goes in parentheses is what you get when you divide out, because we're taking this statement that's already been multiplied and we're rewriting it as a product of two things. So we can divide it out to figure out what goes in parentheses. So 3 goes into 9 3 times. And if I have 5 x's on top, I'm being very explicit here to help you see what we have, then we have 3 left on top. So that means I have 3x cubed. Plus, when I divide here, 30 divided by 3 is 10. And if I have x squared, which is x times x over x, they both cancel out. So there are no x's left. So I'm still getting the same answer. So this is a very explicit, draw it out and figure it out. Or you can look at it and see what the GCF is. If you are pretty good at math, you can go straight from, I can look at it and see what the GCF is, and I can see what goes in here, and you might not need any work. But I would like to see you at least do this step. Not where you draw all the x's out, but at least where you're showing me 9x to the 5th over 3x squared plus 30x squared over the common factor here, GCF of 3x squared, okay? So again, here, I'm not going to do that because when I look at number 3, this looks super easy to me, but I do want to, with number 3, emphasize that for number 3, it starts off with a negative. One of the very first things you're going to have to recognize is when you start off here with a negative, there's a couple of things. You can either rewrite this as 16x minus 4 and factor it this way, or you're going to need to factor out a negative. Okay, so I'm going to show you both ways. This is helpful when one is negative and one is positive, but if they're both negative, you're going to have to learn to factor out a negative, so I'm going to do that with you. So when I look at this, I go, oh, I can divide both of these by a negative 4. So again, like I said, if that's negative, use a GCF that's negative. That's the most they have in common. Now, if you want to go back and use this method, you're welcome to. All you do is continue to break that down, 2 and 2, and that 8 and 2, and then the 8 gets broke down and broke down again. But in here, that means I'm going to put my GCF out front, and then negative 4 divided by negative 4 is positive 1. A positive 16 divided by a negative number is going to give us a negative, so I need that minus sign there. And then 16 divided by 4 is 4 with my x on top. So this is the minimum amount of work that I want to see. When you submit your work for Delta Math, for a quiz, for a test, this is the minimum work. Go ahead and determine what the GCF is, but make sure you are dividing both terms by that GCF so that you avoid any sign errors. And again, of course, we can check it. And we can do the same likewise up here. We can go to Y1, type in our problem, Y2, type in our answer, and go to the table. And if it matches, awesome. Now, if I switch my terms around because I have a positive and negative, then I don't have to worry about having a -4 outside because my GCF here would be +4. Or actually, let me leave some space. So if my GCF is 4, then when I simplify, I'm going to get 4x minus 1 with my GCF on the outside. So why do these two look different? Well, let's see. If I type in my original polynomial, -4 plus 16x in my y1, sorry, let me zoom here, and I type in my answer here where I factored out the negative, always going back to say, did I type it in right? And yeah, it looks like I did. So I'm going to hit second graph. I can see that my tables match. Over here, if I did it this way, is it the same thing? So again, same problem in Y1. And in Y2 this time, I'm going to type in 4 as my GCF and then 4x minus 1. Is that the same? Yes. So that shows you that either method is going to be correct, or whether you do it this way or you switch it around. And the reason is that when you distribute this, you still get 16x minus 1. And here, you still get -4 plus 16x. And we have talked about before in the unit last week that these are the same. I did that wrong. I'm sorry. That should have been a 4. That these are the same thing. Like A plus B is the same as B plus A. Apples plus grapes is the same as grapes plus apples. So the order will not matter. So either one of these expressions would be a correct answer. All right. For number 4, when dealing with no numbers and just variables, you can think of it the same way we did up here. Do we need to write out all the variables? No. If you can look at it and say, oh, I know my GCF is b squared, cool. Then just go through here and divide through by b squared. But some of you may look at that and go, well, how do you know it's b squared? Well, because the only thing they have in common is the variable b, and the most they have in common is 2 of them. You can't say they have 5 in common because b to the 5th power is the product of 5 b's, while b squared is the product of 2 b's. So, again, I'm just going to do this for the sake of students that are like, I don't know what's going on. If you write this out in expanded prime factorization here, A, B, 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 because there are 3 A's and 5 B's, minus 2 B's, you can go, oh, what do they have in common? They have 2 B's, so that's b squared. What's left, that's all, excuse me, I'm sorry, they had 2 B's in common, so I put b squared. What's left is what goes in parentheses. So if I come down here and say I've got 3 A's, I'm going to write that as a cubed. And here I have b cubed. But what do I do if everything got circled? Well, remember that 1 is a factor of everything. So we leave 1 as a placeholder so that when we distribute, we still get the minus b squared back here. So if you circle everything because it's part of the GCF and there's nothing left, use a 1. And I think that's more evidence when you do this and you are able to look at it. So this is the correct answer. By the way, you cannot put this in Y1 to verify because you have 2 variables. So if you're still listening, put over here, cannot verify in calculator. You just need to distribute. Write that down, cannot verify in calculator when there are 2 different variables, okay? So for this one here, if you can look at it and say, oh, all they have in common is b, the most they have in common is 2 of them, so b squared is my GCF. This is the minimum work, again, that I require. Divide both terms by your b squared, and then if there are 5 b's on top and 2 on the bottom, you'll have 3 left up top, which is where a cubed b cubed comes from. And then anything divided by itself equals 1. So I think that often is an easier way to think about why we put a 1 there. Okay? So either way, same answer, 2 different methods. So I know I've gone through 4 examples, and it looks like a lot. It really isn't. The most I require is like that amount of work. It's kind of hard to see. Like that amount of work. That's it. I'm just trying to illustrate it for students who need it broken down. So at this point, I'm going to go ahead and switch over to doing how many? 5 Delta Math problems. There are 21 on your assignment. When I look at number 2, they have what in common? 2 and 5 are prime numbers. They both have the variable x. How many do they have in common? They have one of them because we always choose the lower exponent. So if I have one x in common, then I'm going to put the GCF on the outside and then parentheses and what I get when I simplify this. So remember that x squared is really x times x, and that anything divided by itself equals 1, so these cancel out. So what's left? 2x. Then I bring down my sign. X divided by x cancels out because x divided by x is 1, and it leaves the minus 5. And I'm done. That's all the work that we need. Okay? So if I were to verify it, that's 2x squared minus 5x. That's always a good idea for those of you really good with the distributive property. But again, it uses one variable, so therefore you can verify this in y1. So I'm going to switch over to Delta Math real quick. This was problem number 2. And I'm going to type it in exactly like I wrote it on paper. X, then your left parentheses, then 2x minus 5. And then submit my answer. And I'm done. Okay? So look, they even note here, smallest power between both terms. And again, what should always happen is whatever is in parentheses, they should have no common factors. You should never have 2 even numbers, because if numbers are even, they're divisible by 2. You should have no common variables between these 2 terms here. If so, you have not pulled out the greatest common factor. So you do have multiple attempts on these problems as well to help you out. So if you get it wrong, you can fix it. But like I said, I've got to see some work. So for problem 8 on Delta Math, we have 3x plus 7x squared. Let me refocus that. I apologize. 3 and 7 are prime, so they have no common factor, but they do have an x in common. So I'm going to put, again, x out here. Divide both of these terms by x. My x's cancel. Here, one of them cancels. So I'm going to just make that to the first, and I'm left with 7x. So again, no common factors between the 3 and 7, and both terms do not have the same variable. I can use my calculator to verify, or I can just distribute and say x times 3 is 3x, x times 7x is 7x squared, which is our original problem, so this is correct. So back to Delta Math here. If y'all are doing what you're supposed to, like I can see what time you submit your assignments, and you should be uploading your work as soon as you finish your assignment, okay? Don't forget to do that. All right, so we're good on that. So let's do one that's a little more complicated, because in the examples, they do kind of progressively get not hard, but just a little more involved. So I'm going to do number 11 next. So pause your video, write this down. If you're still listening, put a heart beside number 11 here on your box. Put a heart if you're still listening. So when I look at this expression, I think 30 and 70 are both divisible by 10. So I'm going to use 10 as my GCF, part of it, and then I'm going to compare my x's. And again, this is this is 1x, while this is the product of 4 x's. So the most they have in common is 1x. So I'm going to put an x here, and again, divide both my terms by 10x. When I do that, my x's cancel, and 10 goes into 30 3 times. Minus, because this is negative 70 divided by 10, so that's negative. 70 divided by 10 is 7, And again, if I have 4 x's on top and 1 x on the bottom, 1 cancels out, leaving 3. So that's all the work I need to see. Now again, for those of you that struggle, you can always say, okay, 30 is 3 times 10, and 10 is 2 times 5, and I have 1 x. So this, for those of you that really need the long method, I find that students who struggle with being able to look at it and see, if they break it down into prime factors, they've got it. 70 is 7 times 10, so I'm going to do 7 times 10, but the 10 is 2 times 5. And all of these are prime numbers. And I have 4 x's. So you only need to do this in your notes if this method helps you. What do they have in common? They have a 2 in common. So I'm going to put that down as my part of my GCF. They have a 5 in common. So do times 5 so it doesn't look like 25. And they have 1 x in common. And then I start off with parentheses. What's left in this term? 3. What's left here? 7 and 3 x's. Take this 2 on the outside with the 5x. Multiply it. And we get the same exact answer that we got earlier, just using a method that it uses prime factors. Okay? Always put a box around your answer in your work. That helps us as teachers locate it. Number 18, this is another example where it contains only variables. So you can expand it if you want. You can write out x 4 times, then the y, then 3 x's. Or you can say, oh, the only variable they have in common is x. And the most they have in common is the lower exponent, so 3. So I have x to the third as my GCF. So this is why we did laws of exponents, guys, before. Remember that when you are dividing, you subtract the exponents, right? So that's another way you can think about it. 4 minus 3 leaves 1. Anything divided by itself equals 1. And that's it. Not much work required. But again, if you prefer to expand it, pause this and take the time to expand it out like you did here and see if you get the same answer. All right, number 19, I have 2 different variables, or 21 rather. I don't know where I even got 19. I guess because that one was 18. On 21, I have 2 terms that have 2 different variables. So again, we're still finding what they have in common. So they both have an x and they both have a y. So again, I'm choosing the variable with the lowest exponent to determine what they have in common. So I have 1x over here, so the most they have in common is 1x. And for my y's, they both have 2. So I'm going to have 1x, and I'm going to have y to the second power as my GCF. So again, if it helps, it's longer, but it's a surefire way to get it if you're confused. They have 1x in common and 2 y's in common. So again, that's our x, y squared that they have in common. And then what's left is going to be either what you get when you divide this out or what you have left in your list, okay? So here, if I divide this out, remembering that if I don't see an exponent, it's an understood 1. 3 minus 1 is 2. 2 minus 2 is 0. They cancel out. Here, my x's cancel out, and they cancel out. But anything divided by itself equals 1. Same over here. I have 2 x's left, which is my x squared, plus, remember I told you if they don't have anything left, there is always an understood factor of 1 because anything times 1 is itself. And that takes care of 21. So if we are entering in an answer in Delta Math, I promise I did number these 12, 13, 14, 15, 16, 17, I'm sorry, 12. This is weird that they're not in order. There actually are 21 problems. Let me go back to this account. Sorry for the delay. Weird. I promise I must not have hit save. Oh, boo. All right, so my apologies. I edited this and for some reason didn't hit save. There are a couple more problems. So you enter in exponents the same way you would for any other problem. All right, so there are 20, I think it's 22 problems. I'll have to go back and add those in and make sure that I choose for 21 this problem that we did right here. The only last thing I did want to add real quick is there was one that you might look at it and go, oh, that's kind of hard, but it's really not. Let me see if I can find it real quick. It'll just make your life easier if I had to help you with one more problem, so be patient with me a minute. It was one that had 2 negatives in it. Where's it at? Nope. All these are pretty easy problems. Okay, I guess I can't find that. So if you have any trouble, please let us know. Message us, Zoom, and get your help. But hopefully this video helps you understand how to factor GCFs. Please stay on top of your assignments. Your assignments for today and Friday will be due Sunday at midnight, uploaded with work in Delta Math, or do your Delta Math assignments and complete the uploading in Canvas, because Monday, it's a virtual day for everyone, but you will have a quiz on Monday on this lesson as well as tomorrow's lesson on factoring trinomials with a = 1. If you are done and you've listened to this point, please go ahead and at the bottom of your screen or your notes, write down your favorite color. Whatever your favorite color is, write it down at the bottom of the page. Thank you so much, guys. Have a great day.